Yes.
So we are back after our short break, and Fabian is going to give us a workshop about Gentoo Prefix. I think you are many years in Prefix, so he knows everything about it. So let's see what he has to say.
Okay. Well, thank you, Theo, for the introduction. Yes, I am supposed to know a little bit about Prefix, and I'm going to explain you first why. Let's dive back into the history first, because history is important to understand the current. And it all started basically with Gentoo for macOS X. Remember, if we don't say it like that, then we get some lawyers from a certain company. Which was the PPC macOS keyword, and it was originally in the tree, and it was actually installing on macOS 10. It was installing just in the file system where actually the operating system itself also stored its files. So it was trying to actually install everything it could that did not conflict with the operating system, which sort of worked at the start, but quickly started not working so well, because of course the operating system was equipped with versions of autoconf and many buggy or BSD versions of software that you could not update or replace, and that was simply blocking many packages that would need newer versions of libraries, newer versions of autoconf for building, etc. So generally this approach failed quite miserably, if I'm honest, because it basically meant that it couldn't work, and we had to apply a lot of hacks in the trees with masking of packages and so on and so forth. That really wasn't worth it. So what we learned is not only that it didn't work, but also that we got a lot of resistance from like the Gentoo community as such, because we were actually adding all kind of complex situations to ebuilds, and well, that really annoys everybody because nobody benefits from it. We had to keep in the tree old versions of packages because that was the only thing that you could install, and so on. So what we wanted to do after this situation was like, okay, second attempt, forget about installing everything in the root file system, but instead try to install in such a way that you don't rely on this file on this host operating system, because it simply contains with many outdated packages and stuff that you don't want. So you want to provide as much as you can yourself, because then you can rely on it, much in the way that Gentoo does, because all the ebuilds in the Gentoo tree basically depend on the behavior and the versions that Gentoo basically provides. So an extra thing that I wanted at that time as well is have a very developer-friendly environment. Gentoo already is in itself, and that's exactly what you want to bring to other systems. And in this case, it was my old Mac at that time. And of course, get some essentials that you really need in this world to survive, like Vim and Mud. So this became the Prefix. This became Prefix, which meant we just install everything in an offset. And that offset is arbitrary, so you can pick any place in your file system, like in your home directory, to install like a Prefix installation. And that means you basically install everything, all the files, all the packages that you would normally have in a Gentoo system, up to a point of where it is sane. You don't install a kernel, for instance. In that offset, which means that you have no problem at all with existing software that is outdated or whatsoever. So basically, very much in a nutshell, what you do is you try to imitate a full Gentoo Linux system on a non-Gentoo Linux system, and it does not need to be Linux either. Yes. So what you have is normal is you have a system with a file hierarchy layout like this, and the simple thing that you do is you build a separate offset somewhere and you put everything below. So it's an exact copy. It also has the USR directory and the bin directory. So even this user split merge what people talking about is also affecting prefix, even though the split on a prefix system makes completely no sense. We just completely copied everything. To have for a Gentoo environment a completely identical set but in this offset. So when ebuilds expect something to be in the USR bin directory, then on prefix it's also in the USR bin directory. Okay, so just a little bit of who did what. Michael Heubenwalder, Hobby. He is now a developer. He actually did the first work. He needed it for his, within his company, he wanted to have it. He made a first patch to Portage actually to do this. Then Brian Herring, who was then in his first generation of being a developer, he was actually a Portage developer back then, and he forked off a branch of Portage to create, to work on the prefix branch. Prefix work. That is not what it is today, by the way, because it all went in a different direction. But okay, and then we had Keto, Danja Dietrich. I think he disappeared at some point. His nickname was Keto, and he did a lot of engineering for the first work, especially on the OS X system. He basically got a tree up there with packages in there and a Portage version which worked. But yeah, well, developers disappear, so knowledge also disappears, and yeah, there is by origin not so much interest for this thing of running a Gentoo sort of system on top of something else. At least it wasn't back then, which turned out that you get a hiatus, you just have something and nothing happens anymore because people leave and nobody has time or is not interested. So, at some point in time, we just restarted again, which means you basically start a new implementation on Portage by creating again a new implementation of an offset installation in Portage, which is version number 3 or something. And of course, what you need to really get it usable is have many ebuilds and basically keep those ebuilds up to date or synced, as we call it, with the standard regular Gentoo Linux tree. Because this means that we need modifications to each and every package back then, each and every package to work in a Gentoo Prefix environment. So we had to copy each and every package from the original Gentoo x86 tree to our own. So we copied basically everything, and we kept them in sync, and we had to maintain them. There was a lot of work, but some people actually contributed in that. To give you an idea of how that looks like, I just grabbed this graph from our own stats website, where we keep since 2006 basically the numbers of packages that are in our trees and the keywords that they have. Unfortunately, I don't have a beamer here or a laser pointer, but you can see somewhere in 2010 you have this spike of this gray line on the top. That is basically where we started migrating our tree into the Gentoo x86 tree. So you get an artificial amount of new packages that are in our tree at that point that are actually not prefix aware. So the best you can do is always, what I like the most is you follow the, I think it's cyan kind of colored line, which is the PPC macOS line, which was the first thing that we started with. So it also, back in 2006, it is the one that is basically has the most packages that are available, and up to now it actually still is, surprisingly, because there are only a few people still using it. The two lines for AMD and x86 Linux, I always find them a little bit artificial because they are just inherited from the Gentoo x86 tree. What I just want to say is that we actually did, I think, an enormous work to get up to around yeah, 2,000 packages, maybe even more, that we copied actually from the standard Gentoo Linux tree. We copied and modified them, and then we actually had a habit of having quite some systems that we all used and ported all these packages to. Which is of course not the work of me alone. There are some, well, there's at least one person in this room who did some work on it, and there were some people in the past and people that are not here that actually worked on all these weird systems, which include systems like IBM AIX, which is a system that is not free and you cannot just get it, but still people work on that because in commercial environments people use that stuff because they like it and they really want to have an up-to-date build environment as well. So, nowadays, the prefix portage thing is a branch of the well, the Git repository of Gentoo normal portage. It's just a branch. It is in that way very close to the master. We do have some modifications because we still okay. We still have some different ways, even though we have an EAPI 3 that is prefix or offset aware these days, we still want that every EAPI for us is a prefix enabled one, because otherwise we need to patch a lot of ebuilds. And yeah, for a long while we have, well, I have personally synced all these changes that you have in the standard Gentoo Linux tree into our prefix tree, and that was fairly automated, which for a fair amount of time went fine, but sometimes does not. And that's where you get some statistics numbers in, and yeah, well, you always have to be a little bit careful with statistics. But what it looks like right now, and that's basically also the weird thing of a Gentoo prefix, that it has its own ecosystem in a way. So it has its own rsync generation, which means it also has its own rsync tree, which also means it has its own rsync slaves, which are a couple. We just had a discussion about having some stats, because Gentoo prefix has its own rsync slaves, and only its own rsync slaves. We actually do know a little bit about how many people do a sync, for instance. What we did as an extra is actually we sign everything that is not signed. We did that just for fun. Nowadays, Zach has, Zamedico, the portage maintainer, has added some patches actually to also sign everything in the tree. And we just regenerate like the normal tree does. It's an overlay, so we just take the normal standard Gentoo tree and we overlay our basically our modified packages for as much as we have them. We try to shrink them as hard as we can and to generate our tree. And then you end up with something like this, because a generation of this stuff, and that is something that is basically not related to a prefix in itself, but more that's something that you can learn from actually having to do this, is that if you want to create an rsync tree, like a tree that users use, you have to do a couple of things, and they take a couple of time. And as you can see here, the SVN, our prefix overlay is basically an SVN tree. You can see that the time to update that is very low, so we don't have issues there, but the time to update the CVS GX86 tree is very long. That's not because CVS is so slow, but it's more because there are way more packages. And it's a lot of disk I/O. So you see the large part of actually updating the tree is related to the disk I/O that you have. Then you have eGenCache, which actually generates all these metadata for the tree. That's why if you are a user and you use an rsync tree, it's actually pretty fast, because it doesn't have to source each and every ebuild. eGenCache is basically sourcing each and every ebuild, so it needs to run also for a while. And then you see that it actually takes around 25 minutes to generate such a tree. And then if you only have a half-an-hour rotation slot, it means that you're all pretty much at the edge of how much you can do. The spike you see in the middle is basically when the backup starts on this server, which generates a lot of disk I/O, and there you see that other operations that need disk I/O are going to slow down as well. I do like this figure though, because it shows kind of a flat line, which means that the performance is quite constant. On at least on Solaris, the thing it is running on, of course in a prefix system. Now the prefix itself is very useful for certain scenarios. It does not need any privileges, so it does not need root access. So it means if you're a student and you're at your university and they only give you this interesting distribution of X, Y, or Z, and you want to run something up to date, you could, in theory, just bootstrap a prefix installation, because as a normal user you have enough as long as you have some disk space. And yeah, it looks basically in the file system layout exactly like a Gentoo system, which also means that you have the tools like a Gentoo system has, which is the like you have the Python config stuff, the Java config, the GCC config, you have the eSelect stuff, everything is in there. It's like the same, which makes it a nice development platform. So, of course, you need to do something because you don't get it for free. The whole thing of this offset is that you need to tell whatever the build system is doing that everything should be put into some kind of offset. For this, basically, this is in short the EAPI 3 spec. It does a lot for you in all the helper functions that an ebuild uses. If you're not familiar with them, just ignore it. But it makes a variable available ePrefix, which actually consists of this offset. The offset can be an empty string, which it is for normal Gentoo. And then you can see that if you look at the convenience variable like eRoot, if the ePrefix is an empty string, it just evaluates to root, and the same holds for ed. However, if you have an offset, then actually you get something which is in the offset, which is very nice. However, the most of the work is done basically underwater, in the special helper functions, like for instance econf, where we do not pass prefixes /usr, but we add this is prefix as well, because we need to have whatever it is installed into that offset. So most of it is invisible. In E-classes you can see it everywhere, and it is a big mess, because E-classes typically also do very complicated things that really need to take care of this offset. Apart from that, just to get something in an offset, you also have very nastiness situations in packages themselves. Python is always a very good example. People, upstreams, basically, well, very often live in a world where they think that if you have a stock system, you can just say like, oh, there's a path somewhere in the file system, and there you will find the newest library for X. And that is great if you think that, for instance, on a Mac you are using MacPorts or Think, and the upstream thinks that you're using MacPorts or Homebrew, and that the newest library will be there. However, if you're using Gentoo Prefix, there might be a MacPort as well installed on your system, but you just want the system, the build system, to rely on what your toolchain says. So what on your linker or your compiler says where is the newest library, because in a Gentoo Prefix environment, you don't need to set anything, because your entire toolchain will just cater for you. It will make it transparent for you that you're using something from an offset, which is from a development point of view very nice. But it's also not only about paths and where to find packages, but also many systems like Solaris have an own linker, and the linker is not a GNU LD, and then some packages know that Solaris is using not GNU LD, and you need different flags for that. And well, actually in Gentoo Prefix we just use a GNU LD, so we don't want that. And then last but not least, that's very tricky. Think about an editor like Vim. If you start Vim, it will actually look for its configuration files. And if it just is going to look for the configuration files in /etc/vimrc or something like that, then it will not look at your prefix installed /c vimrc. And that means that, for instance, you won't get all the colors that you want or the completions or something, because it is simply looking at the wrong configuration file. So especially those applications, and it's also like shell, like a bash shell that you want to source the Gentoo profile, you have to patch them to actually tell them like, hey, look, here you have to find the configuration file and not this hard-coded path in /etc, which is actually most of the work that you have to do. For an ebuild, yeah, you have just to make sure, sometimes you just have to tell in an ebuild, like use the library from here, use the include from there, and of course make sure that it installs into the right location, but Portage has QA checks for that to actually help you with telling you that it is not right. One of the tricky things, of course, when you install a package in Gentoo Prefix, is when it installs scripts itself. They are not binaries, so they are just run basically at the moment that you call them. That is post-install. And they may have like wrongly, hard-coded shebangs, like the shell initialization, the first line, which may just point to something outside of your prefix or basically in your host system. Then things will not work like you expect, because if you need a new Ruby or a new Perl and your script relies on that and it suddenly runs an older Perl that comes from your host system, then things go wrong. And also, of course, paths that are in, it's like the config file location, it's in the same in scripts. And well, yeah, there are hard ones like eselect and GCC config that have paths all over because they do a lot of things. Well, but we fixed all of them, and if they are not fixed in Gentoo mainline, they are fixed in our overlay, so whatever you get in our tree, it's all completely fixed. You get an environment that is actually very nice if you want to do development on different platforms. For instance, what I do personally myself, we have a software product and we try to build it and run it and test it on many different operating systems, which includes like macOS 10, Solaris 10, Open Indiana, FreeBSD, Linux, and more of these flavors. And the thing is, what we want is we do not want to test how this particular distribution is or is not outdated or has different libraries. We only want to test if our software product works fine on the kernel and the libc that it provides and the environment and the network stack. So what we do is we just install the Gentoo prefix on it in 32 bits, 64 bits, how many flavors that we want, and we have actually for each and every system exactly the same environment. All the same packages there, same compiler, same libraries, everything. So it's completely identical. So any errors that occur from that are only the errors that are in the system headers, the libc or the kernel, the behavior that's different. And that is very nice because you quickly see if you're going to work with older systems that you cannot build your software because just you're missing an essential library or it's not the right version, and you can try to start work around it, but it's actually a hell of work. So in this way you can just focus on the platform itself and not on if there is the right version of the package or something. So, and this is basically what I wanted to tell you. This is about the theory. The practice is basically that the Gentoo slogan, if it moves, compile it. So, of course, on your laptop, you can install a Gentoo prefix. If it's not running Gentoo already, you can just install a Gentoo prefix on it, which, of course, you have to compile. It's a bootstrapping process. And I heard that the announcement was not gotten through completely, but the idea was if you bring your laptop and you have like not Ubuntu or not a recent version of Debian, you can actually just install a Gentoo prefix environment to actually enjoy the pleasures of Gentoo on your non-Gentoo Linux desktop. For which I have some help in case you want to do. There is a script that actually does everything automatically, but if you don't want to compile right now because you feel like, well, you don't know, you don't trust me, you can also try and visit this address, this IP address, and you can approach it through Rsync and through web, and you can actually find a directory var, tmp, and then something else, and you can find your own system, which includes OpenSUSE 12.2, Fedora 17, Open Indiana, FreeBSD, and Solaris. I didn't have the time to do it for the Mac. And you can just copy it to your var temp, basically in the same location on your file system, and then you should be able to just run the prefix. So that's it.
Any questions?
I was seeking the script and saw there is Solaris 32 bits and Solaris 11, and I'm working in Oracle and I know that the Solaris 11 doesn't have support. I don't know what Open Indiana, but Solaris 11 doesn't have support for 32 bits. I mean the processors only for 32 bits. Does this function, the question is, when you, what you select, it's this car root, or let's say this prefix is 32 bits, or these sections are for, let's say, Solaris or 32 bits?
Well, if I understand your question correctly, then you basically say that on Solaris 11, Oracle Solaris 11, you don't have a 32 bits userland anymore. Is that correct?
Yeah, yeah. There is 32 bits user space, but the kernel does not support 32 bits processors.
Yeah, okay, but that's not a problem, because basically on Solaris 10 and Solaris 9, that's already the same. The thing is that they did support a 32 bits mode, which I think Open Indiana also still does. But if you have a 64 bits processor, it will just load a 64 bits kernel, obviously, because otherwise it cannot benefit from it at all. So the only thing that basically a 32 bits Solaris or Open Indiana install does, it builds a 32 bits targeting userland tool. And if you want a 64 bits one, you can do the same, because the operating system itself is true multi-lib, completely worked out. So you can build basically a new environment targeting 64 bits or 32 bits. Solaris is actually one of the few systems that has a true multi-lib, completely working system, like Mac OS X, which is actually a multi-lib system.
Yeah, yeah. Thank you.
Yeah.
That was the question.
Any more questions?
No. Cool.
Okay. Thank you, Fabian.